All right, so I'm going to build myself a non-inverting amplifier. It makes sense to build the inverting amplifier, maybe to build it first. The trouble is I couldn't build an inverting amplifier because I couldn't find a way to run op-amps with negative voltages. And the reason why I need a negative voltage is if I'm going to run an inverting amplifier, then my output, if my input is positive, then my output's going to be negative. And so the op-amp has to supply negative voltage in order to make that. I couldn't figure it out. But since then, I have figured it out. So here I'm doing the non-inverting amplifier first instead of second. But that's okay. All I have to do is build in Tinkercad this circuit. And this is a non-inverting amplifier. The way that I can tell is you see here on the op-amp, this is the positive input and this is the negative input. And so these are swapped from the way inverting amplifier looks. Anyway, so we know that these op-amps, they run on 22 volts. So I have 22 volts here and I have a ground here because I knew that there was no way that I could produce negative, or I thought there wasn't a way that I could create negative voltages in Tinkercad. Anyway, so I got a 1.5 volts here that's going to go into my amplifier, and it should come out larger. How much larger? Well, nearly the ratio of these two. On the inverting amplifier, it's exactly the ratio. But for the non-inverting amplifier, it's nearly the ratio of these two. It's actually a bit more than the ratio of these two. So 100K divided by 10K gets me 10 times. So my output should be just a bit more than 10 times greater. You can see that it is. I put 1.5 volts in. 10 times that would be 15 volts, and I'm getting a little bit extra zhuzh on the outside of it. So what I have to do is go into Tinkercad and see what this thing would look like prototyped on an actual breadboard. So I'm just going to swap back and forth between the two so I can see what it is that I'm supposed to be doing. Here I have a breadboard, and I put my op-amp in the middle of it, spanning the slot down the middle of the breadboard. And I've already gone ahead and powered the op-amp. My op-amp, you can see, is powered here with 22 volts at the top and ground at the bottom. So here's how I've done it. I have a power supply here, which you can see is running at 22 volts. And I've connected it into my breadboard so that I have ground there and my 22 volts there. Over here, you'll see that I connected the ground on this side of the board all the way over to the ground on this side of the board. That means I have ground everywhere that I want it. The common ground, if you will, to connect things to. I also took the, if I wave over this, you'll see this is the positive power terminal on my op-amp. So I connected that to the positive power. Over here, this one, I wave over it, you can see it says power negative. Now, I'd like to put that to negative 22 volts, but at the time that I was designing this thing, I didn't know that I could make that happen. So instead, I've connected it to ground, and that's going to be okay because my circuit is never going to require negative voltages, and so I won't get into any trouble by doing that. It's a little bit of a cheat. And then I have the other things that are necessary here in order to complete the circuit. You look at this, I need my source voltage, I need 2 resistors, and I need a multimeter, along, of course, with my op-amp. So I have a 1.5 volt source, which is just a AA or a AAA battery. And I have the 2 resistors that I need. This resistor, brown, black, orange, is 10K, and this resistor, brown, black, yellow, is 100K. So I need those. And I have a multimeter here. So all I have to do is sling this thing together from these parts. What I'm going to do to be smart about this is I'm going to take my battery here, my 1.5 volt battery, I'm just going to plug it right in, bang. Notice that the negative terminal of my battery is sharing this row connected all the way to the top with the negative of the power supply. That's the common ground. That's getting everything connected together so we're all in agreement as to what the ground is, that reference level. And so I've got that plugged in. So now I need to go from the positive terminal of my battery Here's my positive terminal. I need to go into the plus on the op amp. Well, I can find the positive input just by waving over. There's the negative input. There's the positive input. And I'm going to connect that to my battery to get my input there. So now my battery is input into the positive. Notice I didn't have to drag the wire all the way over there. All of these holes are connected. So I've got my 1.5 volts going into the positive, or what is technically referred to as the non-inverting input on the op amp, and I've got lots of places to connect other stuff if I need to. Turns out this is a really simple circuit, so I don't need to, but it's nice to know that I can if I want to. So I've got my power going in there. I've got my op amp powered. What else do I need? Well, I have coming out of the negative, the inverting input on the op amp, I'm going through the 10K to ground. So the simplest way for me to do that is to take my 10K resistor, which is this one, and identify the negative input. It's that one. So then I'll take this and move it over here and release it. Bang. I've now connected the negative input to, oops, I made a mistake, look at that. I didn't connect it to ground. I connected it to the positive. That would have been trouble, so I need to boost this up one. Bang. There we go. So now I've connected the negative input to ground. That's exciting. Now what do I need? Not only does that negative input connect to ground, but it also goes through a 100K resistor to the output. I haven't identified the output yet. Let's look for it. Not connected, positive power, output. There's the output. And so I need the negative terminal to come right around, it's on the other side of the chip, so I've got to get around here somehow. So I'm going to take my 100K resistor, because I want to use as few wires as possible. And I'm going to plug it in right there. Bang. Now the right end is connected to the output. I have to take this end and jump over here to this side of the board, and then jump over here to the negative input. So effectively what I have is my negative input goes from the negative input around the board through this 1K resistor and then to the output. If you look at my circuit, that's exactly what happens. I come out of the negative and around through the 100K and back to the output. The only thing that's missing now is my meter to measure out this voltage. So I have my meter right here. What I want to do, you see my meter has a black terminal, a negative terminal, and a positive terminal. So I'm going to attach the negative terminal to my common ground. Everything's happy and connected. I can scoot that over a little bit, make it look really good. I like to make circuits that really look professionally done. Because first of all, I'm a professional, but second of all, I like to do good work. So here's the positive terminal here, and I'm going to connect it to the output. So this multimeter here, which is currently set to measure voltage, you can see that little badge there that says V, is going to measure the voltage of the output. Now what should happen when I hit start simulation is my 1.5 volts here should be amplified so that I should get at least 16 volts on the output. Nervous, here we go, start the simulation. Oh, how about that, 16.5. It did exactly what it was designed to do. This circuit that was designed in iCAD, not iCAD, that's not what I was saying, iCircuit, 16.498 is the output, and when I look at it here in Tinkercad, I get 16.5, positive 16.5. So this took the input of 1.5 volts and amplified it without inverting it. That's what makes this a non-inverting amplifier and extraordinarily useful in building all kinds of electronic projects.